Hello, this is Small Head Big Problems. I'm a small head, and I've got big problems. Today, I'm solving and explaining 3 TMUA problems on camera with no preparation in hopefully less than 10 minutes. Can you beat me to the task? These are problems 1 to 3 from the 2016 paper 1. All right, let's go. It is given that the expansion of ax plus b cubed is 8x cubed minus px squared plus 18x minus 3 root 3, where a, b, and p are real constants. What is the value of p? Um, right, so I mean immediately with this 8, which is a cubed, we see that a is going to be plus or minus 2, right? Wait, I'm sorry, not plus or minus 2, this is not a square, just 2. Okay, that's nice. And then his 3 root 3 is b cubed. Sorry, minus 3 root 3 is b cubed. Yeah, b is going to be minus root 3, right? Because 3 root 3 is, well, root 3 all cubed, right? In other words, it's 3 to the 3 halves. Yeah. So cube it, that becomes minus 3 to the half or minus root 3. Okay, cool. So then basically we're expanding 2x minus root 3 cubed, and we just want the x squared term, which is going to be, by our binomial expansion, right? We got our little Pascal's triangle here. Binomial expansion is going to be 3 times 2x squared times negative root 3. So that's 3 times 4 times negative root, so minus 12 root 3 x squared. So p is just 12 root 3. Is this one of the possible answers? Yes, so it's H. I'll check the answers afterwards. Did you figure it out? Let us know if you found a different solution in the comments. Although I doubt for this problem that there will be. Pretty straightforward. Okay, moving on to 2. The expression 3x cubed plus 13x squared plus 8x plus a, where a is a constant, has x plus 2 as a factor. Which one of the following is a complete factorization of the expression? All right, let me copy this question to the board. So the first thing is x plus 2 is a factor. Okay, so I mean, okay, all these have factors. We don't know what a is, but there's a nice rule which is that well, what am I saying actually? No, I'm being stupid. So f of x is x plus 2 times g of x. Uh, hmm, how can we get a? Oh yeah, no, of course. I mean, x plus 2 is a factor, so f of minus 2 is 0, right? Well, that helps because if we just plug in minus 2 into these x's, basically that just gives us an equation for a. All right, so we have 3 times minus 2 cubed plus 13 times minus 2 squared plus 8 times minus 2 plus a equals 0. 3 times 8, that's 24, plus 13 times 4 is 52, minus 16. So 24 plus 52, 76, minus 16, 50, 76, 60, sorry. So A is minus 60. Lovely. Next, we're gonna divide out this polynomial by x plus 2 to get g of x, right? Uh, I mean, you could use long polynomial division, but it's not really necessary. You can just do a little inspection of the coefficients. It's 8x minus 60. Oh, sorry, no need for the brackets here. is x plus 2 times something. So, well, first of all, the kind of edge terms are the easiest. That must be 3x squared, and that must be minus 30, right? So that these two multiply to that, and these two multiply to the constant term here. Now we have, to get the middle term, we just have to look at one of the other terms, say this x squared term, right? So we have 6x squared from here. So from there, we have a remaining 7x squared that we need, right? 13 minus 6 is 7. So we'll need a plus 7x here. Good to check. Does the x term work? We'd have 14 minus 30. Oh, that's not good. That's 16. What's going on? Oops, maybe I calculated A wrong. Let me see. So 3 times minus 2. Oh, yeah, sorry, that's minus 24. Whoops. So 4 minus 40 plus 52, 12. So A is minus 12. Which means that this here is minus 6. Which means that, does the x term work? The x term is 8. That's 14 minus 6. Yes, that is 8. Okay, great. And so finally, we just need to factorize this one, which is gonna, well, has to factorize to like a 3x and an x. This minus 6 is, let's see, so minus 6 is minus 2 times 3. That's probably likely to work. And we have 3 and 1. So 3 times 3 minus 2 times 1 is 7. Great. So, what am I saying? Yeah, 3 here and minus 2 here. Okay, so it will be x plus 2, x plus 3 is 3x minus 2. It'll be E, hopefully. Okay, lovely. Yeah, did you figure it out? Let us know if you found a different solution in the comments. Okay, I keep maybe forgetting to ask you to try it yourself. Let's see if I remember here. Third question. A line is drawn normal to the curve y equals 2 over x squared at the point on the curve where x equals 1. This line cuts the x-axis at P and the y-axis at Q. The length of PQ is one of these. All right, so try the problem yourself. Pause the video and try it yourself. Let's get this question on the board. All right. I mean, if you can, it's nice to draw a little picture, right? This is a pretty standard graph, 2 over x squared, always positive, and it blows up at 0, and it has an asymptote of the x-axis is an asymptote. Okay, so that's what it looks like. Where x equals 1, y equals 2. There's the point there. And it's normal to the curve, right? So the normal, if that's the tangent, the normal is perpendicular to the tangent, going through the same points. Okay, it cuts the x-axis at P and it cuts the y-axis at Q, and we want the length of PQ. Right, so for the length of PQ, I mean, all we need is well, basically like, yeah, like that y a value of Q, the x value of P, and then, just use Pythagoras. Let's see. So, I mean, this is a little tedious, I guess, but yeah, we just need to differentiate, right? So we know the point it goes through, right? That's the point 1, 2. And to get the gradient of the line, well, we differentiate our function to get the tangent, and then, the perpendicular will be the perpendicular gradient. So dy by dx, let's remember y is 2 over x squared, but that's 2 times x to the minus 2. So dy by dx will be minus 4x to the minus 3, right? Just using your power rule. Or minus 4 over x cubed. All right, so we evaluate it at our x value of 1, give us -4. So the gradient, right, is -1 over that. So just a quarter. Looks about right, pretty shallow increasing line. Okay, so then, I know the kind of formula, like y minus y naught equals m times x minus x naught, right, for a line that goes through the particular point x naught, y naught with gradient m. So I'll just use that. So we have y minus 2 equals a quarter x minus 1. Yeah. At this point, I guess I could just, yeah, I'll just set y to be 0 at this point, right? So that's for p. Y equals 0, plug that in, so we get -2 equals a quarter x minus 1. Multiply it by 4 minus 8 equals x minus 1. So x equals -8 plus 1, -7. Lovely. That kind of makes sense. Okay, according to the picture. Q is when x equals 0. So we get y minus 2 equals a quarter times -1. So y equals 2 minus a quarter. That's 7 quarters. Yep, that's good. Lovely. Okay. And yeah. So let's see. So y is 7 quarters, x is -7. Again, PQ, I just need to do Pythagoras. So let's, PQ squared, right, equals this -7 squared plus, well, just -7, whatever, 7 squared. Yeah. Plus 7 over 4 all squared, which is, let's see, 49 plus 49 over 16. This is all quite long. Like kind of doing like 7 squared times 16 to take those fractions together is a bit long. I'm gonna notice there's like a factor of 7 squared. Okay, that's the square root. Out of these, because that will simplify to a 7, so that's good. And I'll just have 1 over 16, right? 1 over 4 squared left over here. So that's gonna split up into 7 times the square root of 1 plus 1 over 16. That's 17 over 16, or 7 over 4 root 17, right? So that 16 will come out as a 4 there. 7 quarters times root 17. Oh, didn't take in the answers. Yeah, well, that's answer C. Whoop. Excuse me, losing my pen. Answer C. All right, let's go back over this. Here we had E. Let's see if I'm right, right? No prep, I don't know. Here are the worked answers. Question 1, the answer is H. Let's go back up and look. Yeah, H, super. Question 2, the answer is E. Great. Question 3, the answer is C. I have a very bad short-term memory, but I do think it was C. Awesome. All right, guys, if you enjoyed, make sure to like and subscribe. And if you're interested in getting private tutoring, send me a message. My details are in the description. See you next time.